Hey guys, it's Zach Pace here with Impulse Radar, and today we're going to be doing our tech talk on how to locate and map underground utilities with the PinPointR. This GPR cart was designed specifically for utility locating with performance in the forefront of our mind. So it does utilize our dual frequency standard, meaning it's got two sets of antennas in it, one 800 megahertz, one 400 megahertz, both using our real-time sampling technology. And all that really means is that it lowers the noise within the data and creates higher resolution imaging. Now this device does have a 7-hour battery life. It is compact, lightweight, and wireless. So all you got to do is connect to the antennas via Wi-Fi from that intuitive Android controller you see on the handle, which means we have no cables, less things can go wrong out in the field. It does have an internal GPS, which we'll be using today to do our utility mapping. But if you're on a job and require more precision and accuracy, it's seamlessly paired with an external RTK GPS. And then the automatic PDF report generation, I'll show you a little bit later on. It's a great feature. So to connect to this device, we're just going to go into the Wi-Fi on the tablet, try to connect. Now you're not going to get actual internet service. This is just to get the data from the antennas to the controller. Then we're going to open the Viewpoint app, and as you can see in the top right, we've got the battery icon showing the battery status as well as both antennas being active. So we're going to go ahead and start and name a project. I'm going to call it GES Demo 3. You do have the option to add the date to the project name. And then this screen pops up. So you've got your map on the right, and then when we hit this button in the top right corner, the GPS statistics come up. So we're getting a fixed quality of 1, which is raw GPS, and we're getting 12 satellites today, which is really good for non-RTK GPS. And then the HDOP is relatively low, so our precision is pretty good today. We're going to hit the play button at the top and start walking with the cart and see the data scroll across. And then we see these two beautiful hyperbolas come up, and that's what I'm going to be marking today. I'm not quite sure what they are, so for demonstration purposes, I'm going to call this one green, non-potable water. I'm going to put a mark on that and then physically back the cart up. So this red line that's moving, that's the cart backing up using that wheel encoder. Then this one I'm going to mark as yellow, which is gas. Now this is our low frequency view. So this is the 400 megahertz antenna. And as you can see, it's just, you're able to verify that when you're marking in the high frequency that they are at the top of that hyperbola in the low frequency as well. And then we have one more view, the HFLF. This is kind of just a split screen view. And again, it's all up to user preference on how you want to look at that data as it comes across the screen. Next, I'm going to do a quick hyperbola match just to make sure our depths are correct. So you can hit that plus and minus in that box to widen and tighten that hyperbola to get it to match what we see on the screen. Once you're ready, you hit check and you see the depth calibrate on the left side of the screen. And they change a little bit. So we've got our contrast and our gain functions here, as well as a background removal. And I'm going to go ahead and keep on scanning. So I move the cart to about a yard to my left. Do another profile and see those same hyperbolas come into view. Now the screen one does look like it's diving a little bit, which I know is a fact. This is an area we've scanned many times for demonstration purposes, and this yellow one stays pretty linear depth wise. So I am using a gridding technique. In the sense that I'm doing profiles about a yard from each other, but because we have that internal GPS in here, we don't have to mess around with any legitimate multi-line projects, anything like that. We're just kind of using the gridding technique to create our own map. So this is what it looks like physically when I'm doing this demonstration. As you can see, I'm doing a swath, I'm collecting a profile and then pausing it, going back to my baseline and starting another profile, and I continue that process. Now we do have a multi-line option within Viewpoint. So if you want to do a true multi-line grid, you're more than welcome to, but because we have this internal GPS, it kind of enables us to create this field sketch on our own and use whatever technique we like. Now this is what my screen is looking like while I'm doing this scan. As you can see, I'm just doing the profile. I'm backing the cart up to where it's directly over that utility, I'm creating my mark, and then I'm moving the unit a yard to my left and doing another profile. And so I repeat this process over and over to create this map that you're seeing on the right side. Now this map would be a lot more precise if we were using an external RTK GPS, either in a base rover setup or connected to the VRS network. But as you can see, using that internal GPS, it creates this very clear sketch of where these utilities are located and where they're heading, which is the goal. So now, like I said, that green target is diving, so you can see it in the low frequency data, but not in the high. Because it's so deep. It's at about 7.5 feet there, but I only set my window on my high frequency to go to about 7. Now there is an option to extend that window and extend the depth that high frequency goes to, but this really illustrates the idea that having those two separate frequencies is really valuable to get that shallow and deep analysis. So I'm going to close that project out and generate the field summary as well as the KMZ. Both of these are automatic functions that the app does itself. It's going to put those both in a file. We do have a file manager within the app, so we're going to open that up. We're going to locate our project name. I believe it was GES Demo 3. We're going to click on that, and then as you can see, there's the field summary and the KMZ right there. Now on the top right we have our logo. You'll be able to change that to yours, and then we have a quick disclaimer as well. And then the first sheet we're going to have a screenshot of that Google map. We call this a field sketch, but you can clearly see that those utilities are linear. They are going side by side parallel to each other. The second sheet has a CSV containing all your marks, a lat, long, GPS status, and depth. So you can export that into whatever GIS system you'd like, maybe even AutoCAD if that's a route you want to go for your deliverable. And then we've got screenshots of all of the hyperbolas marked. This is just for a QC process to make sure that, there were no extraneous marks. If there were, without being connected to the unit itself, we can go back into the data, select a point, find it in the radargram, and then delete it if we want to. And then, of course, you can go overwrite your field summary and KMZ. You can generate new ones. I was pretty happy with the data, so I didn't want to do that. So this is the last feature that I wanted to show you guys. This is the automatically generated KMZ. And as you can see on this one, the lines are very straight. It's very spatially accurate. That's because this was done using an external RTK GPS. We use the Emlid Reach RS2. If you haven't heard of Emlid, look them up. They've got some great stuff going on. We are a distributor for them. And then if you click on one of the marks in the KMZ, it pulls up the type of utility it was marked as, the GPS positioning information, as well as status, and then a screenshot of the radar. So that's about all I have for you guys today. I hope you enjoyed the demonstration. We are continuously updating this unit, updating the Android interface to make it better. So stay tuned for some advanced geomatics features coming out summer 2021. If you would like to see this unit with your own eyes, we do have distributors all over North and South America, all over the globe, in fact. So don't hesitate to reach out to us. We would love to schedule a live demonstration, get this thing in front of you so you can see the data quality for yourself. I want to thank you guys for your time. Again, I'm Zach Pace with Impulse Radar. I hope you have a great rest of the Global Excavation Safety Conference.